allow me for a brief introduction and brief welcome for Professor Toniolo. As the Dean of this school, and on behalf of the faculty members of our school, I would like to thank you for accepting our invitation and for coming here in Chania. And I hope this event to be a chance for us for further collaboration between our school and your institution. And I wish a very pleasant stay here in the beautiful city of Chania. Again, I will thank you very much for your coming. Please, my colleague, Professor Maravelaki, please say some words about the...
Καλησπέρα σας και από μένα. Σας καλωσορίζουμε σε αυτό τον δεύτερο κύκλο των διαλέξεων του οτιαρινού εξαμήνου. Έχω την πολύ μεγάλη χαρά και την τιμή να έχουμε μαζί μας σήμερα την κυρία Lucia Toniolo. Η κυρία Lucia Toniolo είναι δόκτωρ χημικός και είναι καθηγήτρια της Επιστήμης και Τεχνολογίας Υλικών στο Πολυτεχνείο του Μιλάνο, όπου διδάσκει στην αρχιτεκτονική σχολή μαθήματα σχετικά με το χαρακτηρισμό των υλικών, καθώς επίσης και την ανθεκτικότητα των υλικών της πολιτιστικής κληρονομιάς στις εξωτερικές διαβρώσεις. Η κυρία Τονιόλο είναι πρόεδρος του Ινστιτούτου Πολιτιστικής Κληρονομιάς του Πολυτεχνείου του Μιλάνου και διευθύντρια του εργαστηρίου Υλικά και Μέθοδοι Πολιτιστικής Κληρονομιάς. Είναι επίσης επιστημονικός υπεύθυνος αρκετών διεθνών και εθνικών προγραμμάτων και στις σημαντικότερες ερευνητικές εφαρμογές της περιλαμβάνονται η συντήρηση του γλυπτού Πιετάρον Ντανίνι του Μικελάντζελο, το έργο Μαντόνα in Gloria του Μαντένια από τη συλλογή του Καστέλο Σφορτσέσκο στο Μιλάνο, καθώς και η παρακολούθηση και η συντήρηση του Καθεδρικού Ναού του Μιλάνου, η ανάδειξη και η προστασία του ιστορικού κέντρου της Καστιλιών Εολώνα και σε αυτό το πλαίσιο όλων αυτών των συνεργασιών και των εργασιών της συνεργάζεται με διάφορα μουσεία στην Ιταλία και στο εξωτερικό, όπως το Triennale Design Museum στο Μιλάνο, το Cartel Museum στο Πινάσκο του Μιλάνο και το Vitra Museum στην Βασιλεία της Ελβετίας. Οι ερευνητικές περιοχές της είναι στο χαρακτηρισμό των υλικών της πολιτιστικής κληρονομιάς, στην αποτίμηση των πολυμερών και υλικών νανοτεχνολογίας για τη συντήρηση της πολιτιστικής κληρονομιάς, καθώς επίσης και σε επεμβατικές, μικροεπεμβατικές, μη καταστροφικές, φασματοσκοπικές τεχνικές για την ανάλυση των διαφόρων υλικών της πολιτιστικής κληρονομιάς. Είναι συγγραφέας περισσότερων από 70 επιστημονικές δημοσιεύσεις σε διεθνή έγκριτα περιοδικά, 150 δημοσιεύσεις σε πρακτικά διεθνών συνεδρίων και βιβλία. Οι ετεροαναφορές της από άλλους ερευνητές είναι 1736 και ο δείκτης απήχησης είναι 21. Thank you for coming here. Please.
For everything, I want to thank you, the colleague, Professor Maravelaki, and all the faculty for this kind invitation. For me, is the first time in Crete, and was fantastic this morning that I have walking around in your country and in this town that is really marvelous for the architecture and for the environment. And I am working in this field more than 20 years, and I was involved in many projects. You have heard, but I think that the ideas I have got and the views that I have gained in these years is about what is conservation of cultural property, and in a large and wide range of different materials. This presentation is focused on the historical architecture and a small part on the new materials and new technologies that are being developed in these last years. But please, for anything and for any question, please stop me at any moment, because it's much, much better to have dialogue than to be only a lecturer. The challenge that we face since the early period, probably, of the antiquity, is the conservation of cultural properties is a complex problem. And in this, in the last century, the problem has become more and more complex because of it is strongly related to air pollution. In Europe, in all Europe, the important buildings and historical architecture are generally confined in a space where air pollution is a real great problem. And not only, you know probably well that there are the conservation problem are also connected to the different characteristics of the environment in which they are immersed. And so meteorology, precipitation quality, the deposition of particulate matter, and the atmospheric pollutant, both gaseous pollutants and solid or liquid pollutants are our main concern. So it's important to have always very present the air quality and microclimatic condition in which architecture is effectively standing. What is heritage conservation in Europe? We could say that sometimes, or a very famous art historian in Italy says that probably we have lost half of our sculpture patrimony in outdoor exposition. And this is a war. It's not a problem of defining how, and we really lost. This picture probably, I don't know, is very famous. Many of you can have seen it in books or publications. And is a sculpture on a front side of a church in Munich. And this is a picture dated 1908, and the building was built in 1702. So it was a sculpture standing there since 200 years. What we see is that it is probably, we can say, dirt, we can say have some lack of particulars, but we can see the face, very detailed, this sculpture. The problem is when you see what happened 60 years later. About 1969, this second picture is that, I mean, when I said it's a war and we lost probably half of the whole patrimony. Some estimation says about 50% of outdoor exposed main sculptures have been lost during that period. The period in which the industrial development determined an air quality very highly polluted, and in which the velocity of the degradation process was dramatically increased. And this was a period of about 60 years, beginning in the early 20s of the 20th century and ending about 1980. Now, since that period, the air quality downtown in most European cities has completely changed. So we have a different situation. But what about Asia, for instance? Also, we know very well that if you go through the data of air pollution, the global data, we say that we are in a global world now. And actually, the CO2 or SO2 concentration globally in the world is not decreased. It is decreased in Europe, but not in all the world, and dramatically increased in Asia, for instance. And we saw this very well. This is a very famous site, archaeological site in Cambodia, and this site was famous for this high relief, very beautiful high relief of the Buddhism religion. And this is, you can see, a dramatic situation after, at the end of the 20th century. And this was the relief that a group, a working group of the UNESCO, this is a well-known site listed in the UNESCO sites, and you can see that probably in about 20 years in Asia, we have lost, we don't know what the percentage is of the high relief in stone that we have lost because of air pollution. We can't stay quiet and say that we can restore everything, we can conserve everything, we can face this challenge. We know very well that until the beginning of the 20th century, the rate of this degradation phenomena was very, very low. Then this rate, these are estimation of course, changed completely, and what is important is the same phenomena but another kinetic. So we have the same problem, to face the same problem of conservation, but with a different hurry. And this is true in all Europe. This is nowadays a challenge in Asia. Actually, degradation of outdoor exposed stone materials process is the adaptation of stone material to the prevailing environmental condition. So we have the sensation as architects, planners, that stone are something that doesn't change. Stone in our mind, in common sense, is something very, very durable, that stay there because we have stones that comes from here, Minoic civilization. This is not true. The stones are changing every day, and we know very well this. The stone material is always adapting to new microclimatic conditions. And this where happens. The process happens on the very surface. So what is not the bulk of the stone, not the bulk of the column, not the bulk of a building or a building stone, but the surface. The surface is what generally we want to preserve more, because all sculptures, carvings, paintings, all decorations are on the surface, so that if it's the surface that reacts more quickly, is the surface that we have to protect more. Of course, this is a general statement. What are the factors that affect the durability of architectural heritage? In general, it depends the quality of the material and type and characteristic of the environment. These two factors, these two are reacting together. If we have a very durable material with good characteristics, of course, and a mild environment or not polluted environment, of course, things are better. But if we have a not durable material, a low quality material, and a polluted atmosphere or a very difficult climatic condition, of course, the situation is worse. Which are the characteristics of a material? The chemical, the physical, and mechanical properties. We can define exactly what type of material we do have. We know very well that we have a specific chemistry of the material that can react. At the same time, we can define a specific condition, environmental condition, by the climate. The general climate is a Mediterranean area. We have a general climate. But where is the building? The building is in a specific microclimatic condition, with different thermal excursion, with different wind or UV and solar irradiation. So what is the characteristic of the environmental condition is defined in the site, not in general. And of course, as I said, the most important thing is air quality. We had the chance to follow many important high-value architectural heritage. The first one is the Milan Cathedral that I will present in details to you. It's a very complex architecture because two factors. Very complex for the architectural elements and the different situation at work, the huge surface of the building, and because it is downtown in a very polluted city. This was the scaffold of the last restoration, the last intervention that was finished in 2009, and I will present to you in the following some ideas that what are doing now after the restoration. This is the Certosa of Pavia, near Milan, about 30 kilometers further, in a completely different environment. This is a jewel of the Renaissance period in Italy. It's a particularly important building to which the problems are so difficult that no one had the courage to put their hands on. And so no restoration work were done. When I began my professional work, the first building I saw with my director was the Certosa, and we studied the deterioration patterns, the problems. And since there, it was late 80s or beginning of 90, and no one and no authorization also of the authorities for any project of conservation. You can see many ancient Roman marbles are included in this architecture, so that we are in front of a building that has built with new materials and materials coming from the antiquity. So we can say that this building is something particular. It's a bit archaeological and a Renaissance period building. Very, very difficult to... This is Castiglione Olona, and is called a corner of Tuscany in Lombardy, in northern Italy, because of the architects that worked there and the famous Renaissance painters. And here we have many, many problems due to this small village, we can say. In the 50s, around this small town, an industrial settlement was put down for paper manufacturing and plastic manufacturing. So it's incredible because it's in the countryside, but the pollution was so high there. And all these fantastic frescoes by Masolino da Panicale, was a famous Renaissance painter, were completely destroyed and has been detached from the wall. You know that mural painting is part of architecture. We can say that mural painting is something, is not a painting, but it's more architecture than painting. And going ahead in the centuries, we can think also, and we are thinking now with different projects, to the historical or very high level, high value architecture of the 20th century. This is a famous, the first famous skyscraper, we can say. It is not so tall, but in any case, it's Torre Velasca is a famous architecture by the Milan studio BBPR. Is a very, very famous, important building. And this suffered recently. We were in charge to study the problem of these concrete beam that were completely deteriorated. So, how to face this very difficult situation? We have 4 keywords. Multidisciplinarity. We have to know that these are very complex problems, not easy. It's not enough that an architect plans and make his project alone and study a lot. The problem is to work in team with many different competencies. And this is a keyword. The other keyword is knowledge, because from a side, sometimes I see, still now of course, in these last years, because of the crisis, so also in Italy we have a very deep crisis, economic crisis, we see the projects that are made in conservation for high value, high precious buildings that are made without knowledge, without study, without testing, without really competences. And the third is compatibility. We say that the real keyword today is to be compatible. This is true in the life. We know that we are moving to a green economy, and also in conservation we are moving to a way of thinking that is more compatibility, more durability. So if we put together materials and technologies that are so different, generally the durability is not enhanced. And then we have the fourth important keyword is reversibility and retractability. And for this reason, in this respect, we can say that we have to be serious. Because when you go on the market, I think also here in Greece, all these quality are generally respected in the technical sheet, in the demand. You go to the companies, the sellers, and all the distributors of the product, all they say that are compatible, that are bio something, and reversible. But sometimes these are, of course, lies. And so the architects should be very well aware of what they are proposing. So, project guidelines are something that can grow from these important keywords. I recommend, because I see many students, and so I really say that there is a literature about this, a serious literature. And sometimes because every architect is working in his local context, and this is very good for conservation, they forget that outside there is a word that study a lot and produce a lot of literature. Restoration and maintenance for natural stone. Of course, you probably all know that there are some precise guidelines of the phases of a conservation work. The process is well established, and so it is important then that when we project a conservation work, we follow these phases. They are cleaning, surface consolidation, adhesion and sealing, surface protection, and all this means to act directly on the material at work. And so, what kind of treatment for all phases? What kind of type of treatment for a better conservation? Hori, that is an Englishman, very well known, is a gentleman, we could say, and he said this sentence, that there is hardly a polymer which has not been suggested and used for conservation application. This is true because when polymeric materials were born, in the world of cultural heritage property, all the restorers, the conservators, began to think that all problems were resolved. And there is a polymeric materials, a polymer, a plastic, a varnish for everything, and that is able to resolve all the problems. Polymeric materials, as you know, we have different polymer class, and all these classes of polymeric materials of different producers, of different quality, local of great companies, global world companies, vinyl resin, acrylic resin, polyurethanes, epoxy resin, silicone resins, perfluoropolymers, and so on, all have been applied to different building situation, archaeological sites, and so on. And we found in our work nowadays, when you face a conservation work, you have generally not to have to do with the stone, but with a restored stone. So it's a stone with some polymeric material inside. For consolidation, we have an idea that requirements are very strict, and we want a consolidant to improve mechanical properties of the material. So we have a structure, and you know that this structure is very fragile, sometimes in some condition, and so we have the idea to improve the mechanical properties. And for this, during the time, two great families, we can say, of inorganic and organic compounds were proposed. So this means that we have we can say in Italy, this is true, I don't know here, I know that it's true in Germany, it is probably not so true in England, because these concepts are different in different countries, but in Italy we can say that we have two thinking schools. One that say in Florence that everything should be inorganic because more similar, so compatibility of the substrates, and other elsewhere where polymeric chemistry has been more developed, in which organic esters were more used. For the protective purposes, the protection, the final phase of a conservation work, where we want to realize a protection of the surfaces, a protection from water, from humidity, from rain, from gaseous pollutants, we want something that has the quality to be a water repellent and at the same time a water vapor permeable material. This is like when you say, you know, that technical suit for sport. Now we want to go on the mountains, to very high mountains, with something that is able to resist to low temperature and to permit to the vapor to go out. So it's something that avoid the water inside, to come inside your body, and allows your body to breathe outside. And this is similar with the buildings. Then we want always something that can avoid that the material, the substrate, absorbs water, but we want that, of course, this kind of treatment are materials for surface protection is in general similar to the varnish, a varnish. So it is a coating. And a coating material in general is a polymeric material. Also in nature, we can learn a lot from nature, where different animals, skins, leaf, and so on, are water repellent. And this is because of the natural polymeric material they have on it. So, of course, we have different polymeric materials to act as water repellent, and they are acrylic resin or partially fluorinated acrylic resin, fluorinated polymer, silicone resins, siloxanes, and fluorinated different polymeric material or elastomers. So, in general, for the phase of the protection of stone materials, both natural stone and artificial stone and concrete, we use polymeric coating. When a conservation project and an intervention should be done, we start with a preliminary field inspection and a 3D survey, a mapping and sampling of the different materials and patterns of deterioration. We want to perform a material characterization. It's not something that is already known. Sometimes we say, we well know, for instance, I could say, the Cathedral of Milan is made of one lithotype, is one marble and a specific quality, and everything is made of this marble. But I need the same to characterize the material, because different type of materials, different outdoor exposition, different microclimatic conditions. So, of course, as I said before, the material and environment characterization is really very important. And nowadays, to characterize materials, we have a large variety of different instruments to be used on site. So diagnostic can be made with non-invasive instruments, and we can have a great deal of information not without any damage to the material. These two kind of analysis or investigation can give us the guidelines for the conservation work. And at the end, the conservation projects comes from all the data that have been collected during the investigation work. A conservation project is, in any case, something that should be tested on site. Because it's true that we can have some results applying a product in our lab. But it's not true that the same occurs on site. Actually, we can experiment products, materials, and methodologies in the lab. But the real condition is the same for the doctor that are, when they give us a medicine, you know that each one of us is different and is reacting in a different manner. And so it is possible to try, sometimes we call it pilot yard, to together with the conservation project is very important to make some in-field testing and of the materials that will be used and the methods, the application methods. It's not only important the material, the product, the producer, but it's very important how to apply in the specific case. Some experience in surface consolidation and protection. This is a very, very famous case. In Italy is called this facade of this church is the history of restoration because of the different tentatives that many important architects have made in concern this facade. This is a Middle-Age facade of the 9th century, and the material was very, very difficult. And also in Milan, we have the story of restoration during all the 20th century, because all the different way of thinking and the different products that have been on the market and in which many different architects or directors, in this case, have experimented on this. We can say this is a very famous Lombard Renaissance church, is that church where Leonardo da Vinci has painted his famous Last Supper in this church of the Dominicans. And here is a courtyard of the University of Milan, that is of the famous Ricchini architects during the 17th century. All these examples are, of course, a lot of experience, and I had the chance to be near to this great example, to have seen from the very surface of this building. This is, for example, the marble of Carrara marble. Is a very famous marble of Tuscany, and on your right, Candolia marble. That is this particular marble of the Cathedral of Milan. These two marbles seems similar, but they are quite different, and they react completely different because of this microstructure. The microstructure is Carrara marble is a very fine grains marble. We call it sugaring marble because if it deteriorates, you have the sensation to have in your hand some sugar, and while this other marble is large grain size, And this means that when the touch is something that is not similar to sugar but to sand. What I want to show you briefly is the condition of this marble in 2002, when we begin to see how it was this situation. And this situation was after the restoration of 1972. This marble was completely deteriorated with this disgregation of the microstructure, and was restored with a great amount of epoxy resin. Epoxy and acrylic resin. You can see here, I don't know if you are able to appreciate that here we have a nectar of microfractures. This yellowing is due to the acrylic resin on the surface, and this patchwork of different finishings is due to the use of epoxy resins for consolidation. And when you see a situation like this, it's difficult to understand what to do, of course. The problem is that we have disgregation of the marble, deposits, thick black deposits of the particulate matter, the dry deposition, and everything that was made during the previous restoration. In this case, I can show you that this is a small piece taken in the arm of this sculpture, and you see that, probably, I don't know, that we have here, we don't see the marble anymore. It is epoxy resin, a layer of, we can see in the cross-section. Here we have the marble, the substrate, then a layer of epoxy resin, and on top a white varnish, a titanium alkydic varnish, because they wanted to mask the yellowing of the resin. So this, the real material of this sculpture, after all this conservation work, was a mix of inorganic material, of mineral substrate, and organic material. This is this famous cross-section with the white varnish, with titanium dioxide as white pigment, because the surface of this church was or black or yellow, no more white as the marble expected to be. So also in this case what we could assess during the study of the deterioration process was that, for instance, and this has been published some years ago, that when we had this situation, we could, and this is very, very well known also in many archaeological sites, that we could say that when you varnish a material, no microorganism can grow on it. And we found with some microbiologists that on the Milan Cathedral, many different microorganisms have developed their way of life, and they stayed, you can see here very well, this different stick, small, like worms, you can say, and that they are doing their metabolism, eating the varnish, the plastics, and they were growing a lot on this surface. So it's important to know that sometimes organic materials that have been applied to conserve some monuments in some specific condition can be the substrate for the growing of biofilms. At the same time, you probably know that many acrylic resin, it's very famous also in Athens, the use of acrylic resin on the monuments, and these acrylic resins have the defect, the great defect, but it's normal because there is no material that is able to be durable for decades without any transformation. And these acrylic resins are yellowing a lot and very fast. And so that the Milan Cathedral was covered in the central part by a yellowing varnish that was the acrylic paralloid on it. And this, how was done? This is a small fragment, it's a sample that we took from this area. And how was done? Because at that time, no means of a real cleaning of the surface was done. And at the end, they treated a surface that was deeply deteriorated. So we had the marble substrate, the yellow resin on it, the yellow acrylic layer. But this layer, if you go through this cross-section, we could see that they treated a sulfated surface, completely sulfated. There was salts, mostly gypsum, that was on the surface, on the marble surface, and they treated everything. Marble, gypsum, and all the deterioration material that there was on the surface. So that we had, in a certain sense, we had preserved the deterioration materials. We had preserved with this acrylic vernishing all, and this has, I know that is not the only case, but was occurring very often in that period. What we see here is that very, very quickly, as you can see, that the crystal of gypsum during the time are able to react, to dissolve with humidity, and then recrystallize. And some gypsum is crystallizing inside the acrylic film. And so we could find on the surface some gypsum that was coming out from the acrylic surface. So that, of course, the coating was not effective anymore. And in any case, we can say that, of course, the crystallization of salts is one of the worst problem. And when you varnish, you put a mortar, you put a plaster on a surface that still contains salts, you have to expect that these salts will recrystallize always, and they will come out. So this is also true with the polymeric material. And here we come quickly to see what we are doing now, because all these materials have shown their defects. I generally say, I want to say, and I hope that you agree with me, all the material are deteriorating with time. The marble of the buildings and the conservation material. So we don't have a magic then. We don't have the perfect solution. We don't have the perfect protection treatment, consolidation treatment. We have to study case by case and propose the most appropriate solution for this time, this condition, and this environment. So it's important to understand this. We continue to study, and we have the magic solution. Only the sellers, so all those, and they are right, who want to do profit on the market, they have to sell their products, and is right that they say that they have a very good product on the market, a very effective product. But of course it is like asking to the restorer if his wine is good. Nanotechnologies have invaded in the last decade, the last 10 years, the cement market, the concrete and cement market, because of the idea to set up new cement mix, more increased mechanical properties, increased durability, reduce carbon monoxide effect. You know that the concrete is attacked by CO2 for carbonation. We are aware that the durability of concrete is very low, is about, we can say now, 50 years or 60 years, but we know that after that period, the carbonation process is going ahead and is going towards the rebars, and so the steel bars, and so the problem of corrosion. Nanotechnologies are have the goal of increase all these important properties. And in the last years, the technology of carbon nanotubes is entering in a very, very precise and effectively way in the technology of new concretes to avoid crack propagation. So it's something that is able to reinforce concrete with structures that are, as you know, so small in the nano range that we can, of course, can see them. Nanotechnology has been very important for the new technologies for glass. So the cleaning of glass. This is nanotechnology well developed in the automotive industry and in the developing of new buildings. and also in the coating industry, because the addition of nanoparticles, and specifically silver, zinc oxide, and titanium, have been used for self-cleaning surface and for the decrease of pollution. So we can use it in the public buildings, on the road, and so as to decrease the problem of. And so, like for the other products, if they have applied so widely and with good results to the technology of new architecture, why not to transfer this technology to the conservation of old architecture? And all the experts in this field is now trying to develop and to do this transfer. Of course, which are the tasks? Self-cleaning, depolluting properties, and biocidal property. So these are the most important tasks to use nanotechnology. But of course, this is strictly connected to the use of this specific kind of nanoparticles that are titanium dioxide. This material, as you probably know, I don't know if you are aware of this, titanium dioxide in nano size is a material that has a specific property, that is photocatalysis. Photocatalysis is that this molecule is able to take UV light and promote the destruction, the oxidation of organic different materials. And so they promote the destruction of many pollutants with this very simple product. In our group, we collaborated with other organic chemists, and we synthesized a new titanium, a new type of titanium that is able not only to be photocatalytic with UV light, but also with solar light, because of a specific structure, chemical structure, on the surface of these nanoparticles, so that they can absorb the solar light, being for instance, on the surface of a building, and with the solar light that they receive during the day, they are able to promote photocatalysis. We have done many different experiments in these fields in the last 3 years during a PhD thesis, and we trying to use these kind of nanoparticles by itself on the surface with other consolidants on high porous or low porous substrate, and used together with different stone conservation material. The first one that we have used was, of course, very obvious, was the application of a normal consolidant, it is these well-known materials called theos, as a grafting agent that can be applied on the surface, and after that to apply hydrophilic material on the titania on this substrate. So we have tried to perform a two-layer treatment that can be can have a consolidant effect on the substrate, and at the same time be able to be self-cleaning. So the particulate matter doesn't accumulate on the surface, and the organic material are oxidized. And this situation, of course, proceed in different ways according to the substrate. If the substrate is a low porous material, like a marble, and we tried Carrara marble, it's a specific layer that remains on the surface, while for a porous stone, like a calcarenite, we used the Noto stone, this treatment was going inside the porous structure. We can say that what we found at the, I think this is the most important results that we got from this study, is that the nanoparticle in some condition can react and make some specific bonding with the treatment. And so this is the real way in which we have the nanoparticle inside the treatment, and they act together in a synergistic manner. And this doesn't happen if you mix this together. It doesn't happen if you make one treatment, wait, and then apply the other. But it happens if you put the nanoparticles in the technology wet on wet. So when you apply one, you should apply the other. And this is, I think, a very important idea, because in this way, the nanoparticles are anchored on the substrate, and they can be more and more effective. Actually, I want to see that the evaluation of the photocatalytic activity of this titania during this experiment was about more and more effective compared to the situation in which we had only the nanoparticles. We also applied some blend of different protective treatment on the surface. Blend means that we could mix together the protective treatment and the nanoparticles. And this blend were made with polymeric material having different characteristics. Some are very water repellent, and some are more hydrophilic. So of course, we found that the situation was favorable when the nanoparticles were added to the not the already high water repellent, but to the normal water repellent polymers like siloxane, because we were able to create what is well known in nature, so a critical roughness of the substrate. I'll show you in a minute. Is this one. We have a roughness of the surface that is normal. These are measurements made at the atomic force microscopy, and you have the surface of the marble, and you can see that with the treatment, the blend of the treatment with the nanoparticle, you are going to increase a lot the Z high of the samples, so the roughness of the samples. It's not something that you can control, because normally with profilometry you can see this, because these are nanoparticles. It's not a real roughness that you can perceive. It's something in the nano range. The increasing of this, the increase of this roughness is critical for the water repellency. So to make the surface of the stone really protected. And these are the experiments in the, of course, the contact angle measurements. And these are the photocatalytic effects. So we got, in this case, we got a very nice results. That is, the increase in roughness of the substrate, the nano dimension increase, is very good for water repellency, and at the same time is very good for photocatalytic effect. So we combined two properties of these nanoparticles to give a double result, to obtain not a self-cleaning hydrophilic treatment, but a super hydrophobic substrate. So this was a very, very good result. At the end, because I really know that it's very late for all of you, but Noni asked me to show you what we are doing now on the real surface and on Milan Cathedral. And as I said, there is another keyword that I think that is very important, that is monitoring. Monitoring is to be able to follow the surfaces after the treatment, after the conservation work, and to see what happens during time. So we began in 2012 this project of monitoring of the facade. The facade, as you can see, it's a complex artifact. We monitor, we choose some areas, specific areas, this north pillar and the south pillar, because the facade is west exposed, like all the Christian churches, and but these two pillars are in very different conditions. In one, there is a situation with more humidity, and the other is exposed to south on the corner, and the sun irradiation is giving to the surface a completely different environment. We followed also some specific areas here near these windows because of this hindered surface where the rain is sheltered. Some areas where rain is not arriving, and so we are studying the deposition, the dust, the particulate matter deposition in this area. You can see that we have 5 main sites where we have exposed also, we study the real surface, and then we expose specimen, always, together studying the real surface and expose the specimen. Here, for instance, I want to show you the site for, that is the exposition of new Candolia marble specimen to try all, not all, but some different treatments. In this case, we are always studying new protective materials for this marble. It's a very difficult task, and you can see here we have a site on site with vertical outdoor south exposition, 45 degrees exposed specimen, horizontal exposed specimen, so that we can have on site in the precise condition the different situation. And what we found, specimen sheltered by rain, they accumulate particulate matter, and immediately, this is time 0, this is time 1, 6 months and 12 months. As you can see, you probably know, I don't know, it's very famous, the condition of Milan downtown is high polluted today because of this kind of PM 2.5, 5 and PM 10, so the very fine powders. So this is the great problem now of the conservation of architecture. This kind of powders accumulate very, very quickly on the surface. As you can see, in 1 year we reduced the luminosity, the whitish appearance of the marble of about 30%. So this is 1 year of exposition. When I say that the surface changing very fast, it's because my experience says this. And what about yellowing? Because you know that the climate change today is that we probably have 1 or 2 centigrade more, medium more. And we accumulate organic materials, volatile organic materials on the surface. So that is not only a matter of darkening of the surface, but at the same time is a matter of yellowing. So our surfaces are becoming more and more dark, more quickly, and more yellow. And this is clearly visible also in the same period of time in 1 year, because if you have the new specimen you can see it very quickly. At the same time, if you expose your specimen to washing out, to the rain, to the in outdoor condition, not sheltered, but at the rainfall, you can see in about 1 year, the same time, that the roughness of your material is changing. We have exposed a polished specimen, so we had a very straight profile at the beginning. It's not so low. And we have measured on the surface the laser roughness profile of the at 6 months and 12 months. And we can say that the medium roughness is increasing about 30 or 40%, depends, in a period of time of 6 months. And this reproduces, of course. And this is true if we have the untreated stone, but it's true the same. A small roughness is developing also on the treated specimen on site. So we can say that, of course, we can treat, we can protect the marble, but at the same time we have to be aware that also the coating is subjected to the deterioration by rain wash or rainfall. The same happens for the ability of a coating to be water repellent. At the beginning, this treatment is highly water repellent, was showing a contact angle with water of about 130. It's a very good water repellent, because you know that water repellency is gained over 90. But during time, with this situation of dust and rain, so the exposition to the outdoor condition, after 1 year of exposition, the contact angle is reduced at about 70. So this for us means that the marble is no more protected. And this is true when we observe with a scanning electron microscope the surface. It's very easy to see that on the surface, the treated surface, after exposition, we see these micro fissures, geometric micro fissures that opens in the coating, and this is because it was in very extreme condition. And of course, with these micro fractures, water can go inside and enter the material. So, is it possible to imagine that many of the worker, the colleagues of the superintendents say, but okay, not using anymore any coating, any protectives, any material, any technology, because they are ineffective. I always say that if we don't use anything, we leave a surface like those of marble to the very quick degradation process. These materials are a barrier in any case they are a barrier. There is something that can really be from and separate the substrate, the marble, from the environment. This is always useful, but we have to maintain this. If you have wooden windows, you know that have to paint them each 2, 5, 6 years. And the new concept that now we should have is about maintenance, monitoring, to be aware of what happens on site, and then maintenance. So we can think that a coating, a protective treatment can last 10, 20 or 30 years. We should know that these treatments are very good for a very short time. They can be a barrier for a medium period of time. It's like for investment. You can't have an investment that lasts for and always like this, with the same properties, with the same ability of gaining for 30 years. We can think for short period or medium period. We are not able to think about to have a protection for lasting so long. So the real problem is the reversibility of this treatment, because reversibility, most of the treatment that you use are chemicals, and these chemicals are not reversible in general, because they change during time. For polymeric material, we know that they have a process of changing. So we should know that. So the maintenance is something very serious that should be carried out after a short period of time. Let's say, I say, a period between 5 or 10 years. A coating can't last more than this. So it's impossible to think that. And reversibility means that we will be able to recover or remove the treatment from the surface, but this, of course, is generally not very easy, not realistic. Conservation scientists are not, sometimes I feel, I have a sensation to go around with the superintendents or the authorities in this field and be unuseful, because I'm not able to propose a solution of good durability, lasting forever, and is perfect for that case. And so sometimes I think, oh, I'm real, what I have to do? I think that really the situation is different. We should collaborate and find the best solution, not the magic solution, but the best that we have available now. At the end, I want to thank you, all my colleagues. I have a group of research that is composed of some young PhD students, postdoc students, and researchers, and all what is my experience derived from also from their work. So I want to thank them for their work always, and please visit our website, because all our activities are in some way there. And thank you for your attention.
Lucia, for this very interesting lecture that demonstrates how the diagnostic approach and the interdisciplinary could assist in achieving efficient interventions in the various monuments. Questions, please.
I want to ask you concerning this example that you showed us. The deterioration of the coating in 1 year was a big percentage. So if we compare that with the time that we need to maintain the whole cathedral and the money that we need to do this, is this feasible?
Of course, we could say today sustainable, not feasible. We have to find a sustainable way to protect monuments. We are beginning to talk of sustainable conservation. You have to study the case. If the case is that a sculpture like some that you have seen in this lecture, you are going to lose hundreds of microns in a year. It's better to have a not so efficient protective than losing the surface. So you have to put in this economic balance also the value of what we earn. Of course, if you have some stone, ashlars, smooth, linear, you can also, and the Milan Cathedral is an example of many famous cathedrals in Europe where they generally substitute the pieces. So the elements, the architectural elements, they are going to substitute, to renew, to remake also decorative elements. But sometimes, like that sculpture that is a famous sculpture, is Buzzi in the early 19th century, you are going to lose. You have to choose, or to make a copy there, make a copy and put it in the museum, or take it there and try to face this challenge. There is no way. So your opinion is correct, and is that better to put nothing if it lasts only. It lasts in the perfect condition only 1 year, but after that it is a barrier. It is something that it's making its job in any case. I don't know if I have answered it.
In generally, yes. But I mean, because of the huge size of this monument, that's why I'm saying that you showed us that the scaffolding remained there for 7 years.
Yes,
and then in 1 year the coating was deteriorated 30%. So that's why I was thinking. So this means that it will remain in a scaffold for the rest of its life.
No, because we have to to perform this maintenance work in a different way. We don't want to have the way of thinking is that we always do great emergency conservation work, when all the scaffold is mounted for all the surface and we work for years in that way. No, this is a maintenance work, so you have to make this is the real situation that could be in some way sustainable.
I would like to thank you again for your interesting speech, interesting presentation. Please allow me for a question, because if I'm right, I understood that polymeric material is something like surface protection material. What about larger cracks or mechanically induced cracks, which come from loading conditions, very high loading conditions? What kind of polymeric materials we could use in order to prevent from this situation?
Of course, we are always speaking in this from the beginning of the lecture of the surface deterioration. The structural deterioration is something completely different, and for that the real experience, as you probably know, is that there are not material reinforcement polymer that can only be helpful but never substitute the element, the structural element. So with large gaps in masonry, for instance, of course we know that we could have different reinforcement strategies. So in that case, if you have a pillar or a masonry that has, we do have also the help of polymeric material with mortars, joints, but in general, you know that very well that a pillar is faced with metallic elements. So, and if you know now also the structural new carbon fibers materials, new metallic, very light metallic, all are used in this structure with the help of mortar or combination. Composites, we can say composites. So structural composites, these are, it's really a completely different field.
Other questions? Okay, thank you very much. Again. Σας ευχαριστούμε και για την παρουσία σας.
Thank you for your attention.
Για τους μεταπτυχιακούς οι βεβαιώσεις από αύριο. Δεν είμαστε έτοιμοι για τις βεβαιώσεις.